All right. So operations with polynomials, you have all done this before, which is great. This is all algebra 1 stuff today for the most part. So a polynomial is a monomial, a single term. Monomial is a single term, or the sum of two or more monomials. Now, before we even go any further, I want to go back to lesson 4.1 and discuss the definition of a monomial because it is a single term. However, there are some stipulations, and we're going to run into those stipulations on example 1. And so I just want to remind everybody here before we begin that a monomial, a power function, so something with an exponent that has a positive integer n. Positive integer would be like 1 or 2 or 3 or 4. It's got to be a positive whole number for the exponent. If there's a positive exponent, positive whole number exponent, that means that it's a monomial. So if it's anything other than that, if it's like a fraction exponent or negative exponent or anything like that, it cannot be a monomial. So keep that in mind. All right. So a polynomial is a monomial or the sum of two or more monomials. A binomial is two terms, sum of two monomials or difference. A trinomial has three terms. It's got three monomials. The degree of a polynomial is the greatest degree of any term in the polynomial. We've already dealt with that in this unit. Polynomials can be added or subtracted by performing the operations indicated and combining like terms. So find like terms, put them together. That's for adding and subtracting. You can subtract the polynomial by doing the same thing. The sum or difference of polynomials will have the same variables and exponents as the original polynomials, but possibly different coefficients. Keep the variables and exponents the same with the like terms, add or subtract the numbers in front of them. This is all familiar, I hope. Thus, the sum or difference of two polynomials is always a polynomial. All right, a set is closed. This might be a new definition for you, closed. A set is closed if and only if an operation on any two elements of the set produces another element of the same set. Because adding or subtracting polynomials results in a polynomial, the set is closed under the operations of addition and subtraction. So if you add a polynomial to a polynomial, you get a polynomial. So the set would be polynomials, right? You can't end up with a different type of number or a different type of thing if you combine polynomials by adding or subtracting. An example of this would be if you have, this is a different type of example, but we just got finished talking about like imaginary values, right? So we've got two types of numbers, right? We have imaginary, two main sets of numbers. We have imaginary and we have real, correct? So if you were to ask, is the set of imaginary numbers closed under multiplication? Your answer would be no, because if you multiply I times I, you get I squared, which is what? But remember what I squared equals? -1. So if you multiply imaginary numbers, you can get a real number. So multiplying two imaginary numbers does not guarantee that you end up with another imaginary numbers. Therefore, it is not closed because you end up with a different element when you multiply them. However, if you add imaginary numbers, if you have like I plus I, you get not I squared, you get 2I, sorry, 2I. So that doesn't mean, though, that it's closed under addition because, I mean, you could have -I plus I. What would -I plus I equal? 0, and 0 is a real number. So it's actually not closed under addition or subtraction either. You might think it is, but there are examples of it making a real number. So those are the types of things that you think about when you're talking about like closure. If you think about integers, if you multiply an integer by an integer, you will always get an integer. Positive or negative whole number multiplied by a positive or negative whole number will result in a positive or negative whole number. So those are the kinds of things that you're thinking about when it asks you if something is closed. It is closed under addition and subtraction. It just straight up tells you that. So that's kind of nice. All right. So you're going to determine whether each expression is a polynomial. If it's a polynomial, state the degree. So A, right off the bat, like I mentioned, this says this is not a polynomial because we just reviewed the definition of a monomial. And it's because of this right here. A root of any kind. This is a cube root, by the way. And this is something that you haven't learned yet, and you will learn it later. But if you have a radical over a variable, the cube root of x, cube root just means what number multiplied by itself 3 times instead of 2 times from square root. This is equal to x to the power of 1/3, which is not an integer. And we'll talk about this later on in probably algebra 2b, but this would be what's called a rational exponent because rational numbers are generally referred to as fractions. So because this is not an integer exponent, that means that the cube root of x is not a monomial. So if you have a square root over a variable or any kind of radical over a variable, that thing will not be a monomial because it does not produce a whole number exponent or an integer, positive integer exponent. So not a polynomial. However, this one is, so this one is a polynomial because each term is a monomial. There are 3 terms. You've got 5a to the 4th b. The middle term is 3a squared b to the 7th, and the last term is -9. The degree of the first term is 5, not 4. Why does the first term have a degree of 5 and not 4? Yeah, because b has an exponent with it as well, and that exponent would be 1. So this whole term here, we've got a 4 with the a, an exponent of 4 there, plus 1 more with the b. So that would be an exponent of 5. The degree of the second term is what? 9. So what's the degree of the polynomial then? Kind of our question. An interesting, I think. What is the degree of a polynomial or a monomial? No, because when they're together like this, we're just going to add them. We're not going to multiply exponents unless we multiply the same variable by another variable that's the same, which we'll see in this lesson. But all you do to figure out how many degrees are in a particular polynomial, you just add up all of the exponents in that term. We're not actually doing like math with anything right now. We're just determining how many exponents we have, because this is a times a, right? And this is b times b times b times b times b times b times b. So we've got 2 a's and then 7 b's. So exponent total would be 9. Okay. What's the degree of the polynomial? What's that? No. How do you find the degree of a polynomial? What's that? 9. Yeah, it's 9. The degree of the polynomial is 9. It's just like what we saw wrapping up lesson 4.2 about 15 minutes ago. Right here, this polynomial has a degree of 4, even though there were other terms with other exponents. The degree of the polynomial is always the highest amount of exponents with the single term, like the greatest single term with the exponents is always going to be the degree of the polynomial. And we saw that back with lesson 4.2 and lesson 4.1. So we're not going to add up all of the exponents throughout the entire polynomial. We're just going to take the single highest degree term, and that's the degree of the polynomial. All right, now this one right here. See, the expression is not a polynomial because there are 2 terms here with negative exponents, and we can't have negative exponents. We need positive integer exponents, and so neither x to the -5th or x to the -3 are monomials. So only one of those 3 was an actual polynomial. All right, let's look at A. What's the degree of the polynomial? 7. Good. For B, what's our degree? 9. 7 and 2 is bigger than 1 and 1. This is a degree of, this term has a degree of 2. This term has a degree of 9. Therefore, the polynomial has a degree of 9 because it's always equal to the largest degree. C, what's the degree? 10. All right. D, what's the degree? I heard 1, and I think I heard somebody else say something else. How come? There's no what? Yeah, there's no variable. If there's no variable, then we're not talking about an exponent. So degrees have to do with the exponents with the variables. And then you can even see here with part B that we just saw. So the degree of the third term, -9, is 0. So if there is no variable with it, then that particular term has a degree of 0. All right, turn the page. Adding polynomials. All you are doing here is combining like terms. That is it. It probably looks a little bit more complicated here than it needs to be. So I would not use the associative or the commutative properties here by grouping like terms. I would just probably look at what's there and combine the like terms. If you want to use like highlighters and match up the colors for things, you're welcome to do that. But we have a term in here, 6x cubed and x cubed. Those both have an exponent of 3, so we're allowed to add those together. We've got a 6 here with that one and a 1 here with that one. 6 plus 1 is 7, so that's 7x cubed. This is just like pretty basic algebra 1 stuff here. 7x squared. No other x squareds in there, but there's a minus 4x squared over here. 7 minus 4 is 3. So that would be 3x squared. We got a negative 2x inside the parentheses here. And a minus 8x over here. What's negative 7 minus 8? Oh, sorry, negative 2 minus 8. My bad. Negative 10, sorry. Yes, not negative 7. And then finally, we have ourselves a plus 5 here, and we have ourselves a positive 1 here. 5 plus 1 is 6. There's a couple, there's different methods that it's showing you. Honestly, I wouldn't use method 1 or 2. I would just do exactly what we just did, and you can get your answer by figuring out your like terms and then just combining them and be done with them. This is grouping. It's actually rewriting it to group up the degrees terms with the same degree terms. You can, but I feel like all of you have probably done this type of stuff enough that you could probably just look at this and be like, oh, those are the like terms, I'm going to put them together. You can add them horizontally if you want to. This is kind of like when we used elimination for solving systems of equations, except these aren't equations. There's no equals. You're just putting together like terms. That's an option as well, but you don't have to do that. So what I want you to do is do the check step. I'm going to give you 30 seconds to do the check step. Just be really careful about which ones you put together and maybe which ones you don't. All right. So we should be looking at 6x cubed plus 2x squared minus x. Nope. Plus 11x. There we go. Minus 3. So 6x cubed plus 2x squared plus 11x minus 3. Good? Good. All right. For subtraction, it's not really any different except for the fact that if you have a polynomial within parentheses, you need to distribute the negative. That negative has to apply to everything in that second set of parentheses. So don't forget to do that. Other than that, it's the same as what we just did. Now, you can distribute and rewrite the entire function or rewrite the entire polynomial. I'm fine with that. And that's exactly what they did here. So that would be the distributive property here. Or if you're comfortable with subtracting and subtracting negatives, you can go straight from here to the answer. So if you want to distribute it all out, you can do that right here. And then if you distribute everything, you can just drop the parentheses and then combine your like terms. That's fine. Generally, though, I would just do this without actually distributing, knowing that the negative has to apply to everything in here. So I'd look and I'd say, all right, 2x to the fifth power, nothing else has a power of 5. So 2x to the fifth power is what we're starting with. And then we've got 11x to the fourth power minus 5x to the fourth power. So 11 minus 5 would be 6. So it would be plus 6x to the fourth. And then x cubed. There is no x cubed here in the first set of parentheses. There is in the second one, and it's a negative. The negative applies to the 9x cubed. So I'm going to write minus 9x cubed. In terms of squared, nothing has a squared here. So there is no x squared term on this one. Regular x, we've got 7 minus negative 3. That negative and that negative multiply to make it a plus. So 7x minus negative 3x would be 7x plus 3x, which is 10x. And then negative 8 minus 4 would be minus 12, or negative 12. So you can distribute the negative if you want to, or you can just think about what would happen if you distributed the negative and combine your like terms to get your answer. That's it. There's also the vertical method if you want to use the vertical method. I generally just do these in one step, and you're welcome to do these in one step as well. Try the next one. I'll give you a minute on this one. All right. So let's see what we got here. Is there, actually, what's our first term? This is an interesting one. Negative 5x cubed. Good. There is no x cubed over here, but there is over here. And if you apply the negative, that'll be negative 5x cubed. And you always have to go in descending order of the exponents. That's our first term. What's our second term? Which one? 6x squared. Yeah. 8x squared minus 2x squared would be plus 6x squared. We got x here, x here. What's it going to be? Plus 3x. Good. So plus 3x, because a negative 3x minus a negative 6x would be negative 3 plus 6. Yeah, here we go. Did you start with the negative 5x cubed? Uh-huh. Yep. Oh, this one wasn't cubed, though. That one's squared. So I think that's what happened on that. So yeah, as long as you're paying, like, you just got to pay really close attention to what the value of the exponent is. And so, yeah, if you're matching up like terms here, that squared would go with that squared there. This is the squared would match up. And then this x would match up with that x. And then the 1 is going to match up with the -9 there, which leaves this guy 5x cubed out front all by itself. Cool. All right, so the last term, what's the last term here? Plus 10, yeah. Good. All right. So adding and subtracting polynomials. Great. Next, FOIL. All right, I'm going to be real quick with this. You all know FOIL. We've used it a bunch already. Now, this first one doesn't actually use FOIL. It just uses the distributive property. So all you have to do is take the number or the term outside the parentheses and multiply it by everything on the inside. And again, I wouldn't even bother with this step here, even though it's written. We'll go ahead and fill it in. I would just go straight from here to the answer, just because you all are able to do that. This is stuff that you did lots and lots and lots back in Algebra 1. So if you're using this method here where you actually write out that second line, which again doesn't really make a whole lot of sense to me to actually do that at this point because you have a lot of experience with it. This is going to be 2x times, that'll be a 5x squared there, negative x, and then 2x times, what's the last one, -7. So I would just go ahead and say 2x times 4x cubed. 2 times 4 is 8. And then x cubed times x, you would add the exponents together. 1 plus 3 would be x to the 4th. So this is where we start adding exponents. When you multiply terms together and you have the same variable, you add the exponents with that same variable. If the variables are different, don't add the exponents. You can only add the exponents when the variables are the same. 2x times 5x squared would be 10x cubed, which is already there. 2 times -1 would be -2. X times x is x squared. And then 2 times -7 is -14, with an x would be -14x. Right. All right. Distributing, that's all we're doing there. Now this next one has 3 sets of parentheses that are being multiplied together. We've already done this. So stuff you've done before as well. Pick any 2 of them to multiply together first. It doesn't matter which binomials you multiply together first. Whichever ones you pick, use FOIL. And it's having us multiply the first 2 together. So let's do that. So first times first would be 3a times a. The a goes there. And then the outer terms would be 3a times -7. The inner terms would be 5 times a. And the last ones would be 5 times -7. Again, this is a step that I would not actually do. I would just start off with this next one. Because the first times first would be 3a times a, which is 3a squared. Outer, 3a times -7 minus 21a. Inner, 5 times a is 5a. And then last, 5 times -7 is -35, so minus 35. And the 2 terms in the middle, most of the time, not always, but most of the time, the 2 terms in the middle are going to be like terms, and you can just put them together. -21 plus 5 would be -16. So you end up with 3a squared minus 16a minus 35 when you multiply those 2 binomials together at the beginning of the problem. However, there is a third binomial. So now that you have this quadratic trinomial, you're going to multiply it by 4a plus 1, which means everything in the first set of parentheses multiplies by everything in the second set of parentheses. So, you know what? I'm just going to get rid of that. I don't like this second step that they keep including. So, all right. I would start just by saying, all right, I got 3a squared. Good morning. We got 3a squared. We're going to multiply that 3a squared by both 4a and by 1. So we'll start here, 3a squared times 4a, and then 3a squared times 1. That'll be the first thing to multiply together. 3a squared times 4a. 3 times 4 is 12. A squared times a is a cubed. And then 3a squared times 1 is 3a squared. And then we do -16. A times 4a. -16 times 4 is -64. A times a is a squared. So there's that -64a squared. And then -16a times 1 will be -16a. And then finally, we're going to multiply -35 times 4a. That'll be what? -140a. Yep, there's that. And then -35 times 1 would be -35. So everything in the first set multiplies by everything in the second. Then you look for your like terms and combine them. In right here, so the third, no other thing to combine with that, but 3a squared minus 64a squared. What's 3 minus 64? Yeah, so minus 61a squared. And then negative 16 minus 140 is negative 156 with the a there. And then at the end, minus 35. All right. I'm going to give you 2 minutes. I want you to answer this one here, the check step. I would highly recommend using the margin over here. So FOIL, and then once you've FOILed, you're going to have 3 terms, and those 3 terms will multiply by the final binomial. So take 2, maybe even 3 minutes on this one, and then we'll move on to the last page. All right, how do we do? Any questions? Negative 10r cubed minus 53r squared minus 49r plus 12. In terms of the work, I just multiplied the first 2 binomials together. So negative 2r minus 3 times 5r minus 1 turned into negative 10r squared minus 13r plus 3. And then that multiplies by r plus 4. Distribute all 3 of these terms, multiply by both of those for all 3 of them, and you get negative 10r cubed minus 40r squared minus 13r squared minus 52r plus 3r plus 12. Nothing combines with the negative 10r cubed. The 2r squareds combine to be negative 53r squared. The 2r terms turn into negative 49r, and then the plus 12 stays by itself. Questions? Cool. Last page. Here we go. Last page, last question. All right. That's a big cake. So, write and simplify a polynomial expression. Byron is baking a 3-tier cake for a birthday party. Each tier will have half the volume of the previous tier. The dimensions of the first tier are shown. Find the total volume of the cake. Aha. So, if we knew the volume of each of the tiers, what would we do with those volumes to figure out the total volume? You would add them together. Good. So if we knew the volume of the base, tier 1, and we knew the volume of tier 2 and we knew the volume of tier 3, we just have to add all 3 tiers together. Everybody cool with that? All right. Describing the task in your own words. List any questions you might have. Let's see. So we need to find the total volume of the cake. So that will be the task at hand. All right, how will you approach the task? Well, find the volume of what first? Tier 1, then, and then tier 3. So find the volume of all 3 tiers. And then what? Once we have the volume of all 3 tiers, what do we do with them? Add them together. All right. Then them together. Okay. Use your strategy. Okay, let's do it. So tier 1. Hope we have enough room. We can use the margin if we need to. Yeah, probably need margin. So I'm just gonna head over here, say tier 1. I'll just put a 1 next to it for tier 1. And that volume is going to be x times 4x minus 3 times 2x plus 1. I'm going to distribute this x into those first set of parentheses, because that'll just give us, that'll be 4x squared minus 3x. Times 2x plus 1. So multiply the x into it, and then we can use FOIL here. So that'll be, what happens when we use FOIL here? What's our first term? 8x cubed, outer. So f is 8x cubed, O is what? Plus 4x squared, I for inner. Minus 6x squared, and last, minus 3x. Okay. The 2 in the middle should be able to go together. So 4 minus 6 is negative 2. So tier 1 has a volume of 8x cubed minus 2x squared minus 3x. All right. Everybody good at that? So volume of each tier. So tier 1. Over here. 8x cubed minus 2x squared minus 3x. All right. What does it say about each subsequent tier? Half. Yeah. So we don't actually have to do FOIL again. We just have to cut this in half. So tier 2 is going to be equal to 8x cubed minus 2x squared minus 3x divided by 2. Which equals what? Four x cubed minus x squared minus, you say 3/2, or it's a decent decimal, 1.5x. All right. So tier 1, tier 2 is 4x cubed minus x squared minus 1.5x. All right. And then tier 3 is equal to half of that, right? So tier 3 would be, that would be 2x cubed minus what? 0.5x squared minus, what's half of 1.5? 0.75x. All right. So tier 3 is 2x cubed minus 0.5x squared minus 0.75x. Total volume then would be, here we go, 8x cubed minus 2x squared minus 3x plus 4x cubed minus x squared minus 1.5x plus 2x cubed minus 0.5x squared minus 0.75x. All right. Now this one, I am going to go ahead and highlight because there's a lot going on here. So there's a x cubed there. Here's another x cubed here. Here's another x cubed here. I just don't want to forget about anything. So if we forget a detail at this point, shame on us. All right. We've made it this far. Okay. There we go. 3 sets of like terms. 8 plus 4 plus 2. 14. All right, so 14x cubed. Negative 2 minus 1 minus a half. Negative 3.5 minus 3.5x squared. Negative 3 minus 1.5 minus 0.75. 5.25 minus 5.25. Yeah. So minus 5.25x. Let's see. I don't see any units of measurement here, inches or anything like that. So we're just not going to say anything about units of measurement. So there's our volume. V is equal to that. Cool. What would be a good way? We can just talk about this last one. We don't actually have to do it, but what would be a good way to verify that what we have done is correct? Down here. How can you know that your solution is reasonable? Don't worry about writing anything. We can just talk about it, but what do you think? What would be a good strategy for checking the solution? Anybody? Is this an actual volume? No, that represents a volume. How could we find an actual volume? Choose a number for x. We're not going to, but we could. If you choose a number for x and you plug it into tier 1, you would get an actual number for the volume. If you plug that same number into tier 2, you would get an actual number for that volume, which should be exactly what of that? It should be exactly half of that. So if tier 1, if you plug in a number for x, and let's say you get 100 for tier 1, tier 2 should be 50, and tier 3 should be 25. Yeah. So that's how you could double check it just to make sure. We're not going to, but you could. Okay. Your assignment, lesson 4.3. Because you've done a bunch of this type of stuff before, we're going to do 1 through 47 every other odd. So it's going to be not a whole lot of problems to do. So 1 through 47 every other odd. All right. that is it for that. Now, the last lesson of the entire trimester, we're going to go ahead and do that probably tomorrow and Wednesday. And then like I said, we are going to do some sort of like quiz-ish thing at the end of the week, but it'll be pretty different than what we've done for the other tests. So